All right, so this is the review of the graphing worksheet for the semester 1 exam, and this is actually take 2. My iPad shut off in the middle of my last take, so some of these first problems have been completed, but I'll just kind of talk my way through these. Number 1 is an absolute value function. The vertex here would be at the opposite of -4, which is 4, 3. So over 4, up 3, and because it's a negative up here, I'm going to reflect this downward. So my slope is down 1 over 1, so I have a v pointing down. Number 2 is a square root function, and the parent function starts at 0, 0, and it works slowly up and to the right. My center of this, and I actually rewrote this so that we can understand this a little bit better. The negative is going with the x, and the 2 is a plus 2, so actually this is not correct because I should be shifting to the left 2 units. So let's ignore that. I'm going to start here. And because the negative is with the x, I'm going to shift to the left. So this is actually the right graph. Number 3, I have a starting point at -3, -2. So that would be -3, -2 right here. And instead of going up slowly to the left, because the sign is outside of the absolute value sign, I'm going to go slowly downward and to the right. Instead of going up slowly to the right, I'm going to go down slowly. And the difference in between these, if I look back at number 1, I know when the negative is outside of the absolute value sign, it points downward. So when the negative is outside of the square root side, instead of going up, it's going to go down. Okay, whereas the negative inside any function with x, whether it's quadratic, square root, absolute value, we would shift left or right rather than up or down. Okay. Number 4 is linear, so go down 4 to the y-intercept, and then my slope is up 5 over 1, and I get a line. Number 5 is a piecewise function, and with this I have 3 sections of the graph. One section is to the left of 0, so I'm working this way. Then another section is between 0 and 2, and then a third section is to the right of 2. So the first section here, the negative numbers, is made up of a quadratic function, and instead of my vertex being at the origin, I shifted down 2. This is an open circle because it doesn't equal, and my parabola is just pointing upwards. So it's just this part of the parabola that's in this graph. In between 0 and 2, this is a horizontal line at 2. So I go up to 2. It does include the value at 0, so it's a closed dot, and a horizontal line over to 2 on the x-axis, and it doesn't include 2, so it's an open dot. This last part, y equals 2x plus 3, for numbers that are greater than 2 or equal to. So I got a closed dot here. Now where I find where I'm starting, I'm just going to plug in 2 into my equation. So if I plug in 2, 2 times 2 is 4, plus 3 is 7. So 2, 7 is my starting point. That's right here. And then from here, I'm just going to apply the slope, and I'm going up 2 over 1, up 2 over 1. So this is the correct line, not here. It's a good thing I'm going over this again. I made a couple mistakes. Number 6, I have 2 sections to this piecewise function. This time, I'm kind of divided here to the left of -1. So my starting point here, if I plug in -1, the opposite of -1 is 1, minus 2 is -1. So I'm going to start at -1 here. Technically, my slope is going down 1 over 1, but since I want the numbers to the left of this, the numbers that are less than -1, I'm going up 1 and over 1 this way. Then I have values that are greater than 0. And again, this is a parabola. And instead of my vertex at the origin, I have my vertex at 2. And it's just this side of that parabola. And there aren't any values in between -1 and 0. So this is just kind of an open spot here. All right, number 7. This is a quadratic function, and I'm going to choose to do this by graphing or by factoring, and I have a +6 and a -4 multiply to be -24, add to be +2. So my x-intercepts are -6 and 4, so I had graphed those already. I do know that I have a line of symmetry that is half the distance between these two, so that would be at -1 is my line of symmetry. Whoops, x equals -1. And then here, one thing I can do is I can find out the y-intercept. I know the y-intercept would be -24, so this is 0, -24. If I plug in 1, I get a -25. And that's because -1 squared is 1. -1 times 2 is -2. So 1 minus 2 is -1 minus 24. My vertex is at -25. -1, -25. And this would be my parabola. All right, another quadratic function. This time I have one that is in vertex form, so automatically I can identify the vertex, which is at -3 and -2. So here's my vertex, and I know it's pointing down. And if I wanted to be a little more exact with my points, I can pick a value that's close to the x value of my vertex, like -2. I can plug that in here. -2 plus 3 is 1. Squared is 1. Make that -1, multiplying by -1. So -1 minus 2 is -3. So here I would go down 3 units, and I have another point here. Number 9 is a circle, and my center is at the origin. My center is 0, 0, and that's because there are no values being subtracted from x or y. And my radius is 4. 16 is r squared, so my radius is 4. So if I connect these points in a circular fashion, there's my circle. Number 10 is close to a circle, but I have a plus, so this is an ellipse. My center is at the origin. Along the x axis, remember this is in this case, this is b squared, because it's the smaller number, so 4 units away from the center. And this is a squared because it's the bigger number, so this is 5 units away from the center. And I can draw in my ellipse. And I also need to find my foci, which come from the equation b squared equals a squared minus c squared. And if a squared is 25 and b squared is 16, 25 minus 9, so c squared is 9. 25 minus 9 is 16. And that means my c value, or the foci, is 3 units away from the center. So there are my foci. And these are vertices and my center. Number 11, similar equation, but this time I have a subtraction sign between them, so this is a hyperbola. And it's going to be long because y squared comes first. And my vertices are going to be, this is a squared, 4 units from my center at the origin along the y-axis. Oops, these are vertices. I have some co-vertices along the x-axis, which really, remember, are only used for helping us make this box that will help us draw the asymptotes. Through the corners of the box and through the center. Now the equation of this line, I'm looking for the slope, and it's up 1, 2, 3, 4 over 3. So my asymptotes have an equation of y equals plus and minus 4 over 3 times x. Now I also need my foci, and that comes from the equation a squared plus b squared equals c squared. So I have 16 plus 9 is 25, so my c value is 5 units away from the center. 1, 2, 3, 4, 5. Here's my foci. And I can just draw in my curves now. Remember, the foci has to be farther away from the center than your vertice in a hyperbola. In an ellipse, the foci are inside the center, so they're closer to the center than the vertice. All right, so number 12. 12 is a parabola, and I know this because only one of the values are squared. And I'm going to have a vertex, or a center, or yeah, it's a vertex, of the parabola be at the number subtracted from x is -1. The number subtracted from y is 3. -1, 1, 2, 3. So here's my center. And it's going to open in a positive direction because this value is positive, so it's going to open to the right. If it were x squared, like in a quadratic function, it would open up or down. Because it's y squared, it opens right or left. This 8 is 2a. So my a value is 4. So that means 4 units from the center, 1, 2, 3, 4, is my focus point. And then 1, 2, 3, 4 units this way is my directrix. And this is a vertical line, and this is -1 plus 4 at -5. X equals -5. Number 13, here I have a polynomial function. So what I need to do is look for my x-intercepts. And my x-intercept here is a -3, This one is -1, and this one is 2. If I look at the multiplicity of each of these, because this is an even number, I know I'm going to have a bounce at -3 and a bounce at 2. And here it's going to go through -1. Another important thing to find here is the degree to determine if it's odd or even. So I have 2 plus 1 plus 2. So 2 plus 1 plus 2 is 5. So my degree is 5th degree, and that's odd. And that tells me that my arrows at the end behavior, one arrow is going to point up and the other arrow is going to point down. All right, so here, actually, I'm going to start going up and then I'm going to end going down. Nope, the other way was right. Sorry. Let's get those intercepts on here. So I have -3, and then -1, and then +2. So in a positive, I start this way. So I'm going to hit -3, and it's going to bounce. So I'm going to go this way and this way. So here I'm going to come back, and I'm going to go through -1, and I'm going to turn, and I'm going to hit 2, and I'm going to bounce here and end up going that way. Okay, so because all of this was a positive, I start from the left, I'm going to go up, bounce at -3, come down, go back up to get to my x-intercept. I'm going to go through, I'm going to turn, come back and bounce at 2, and then go up to infinity. Number 14, this is a power function, and because my degree is even, 10 is even, I'm going to have something that has a parabolic shape. And my vertex is going to be at 1, -6. So here's 1, 2, 3, 4, 5, 6, -6. And because this is positive, it's going to kind of go upward very fast. And that's what that looks like. Number 15 is also a power function. This time, my degree is odd. So this is going to take on the shape of a chair function, but because it's negative, I'm going to start not from below and going up, I'm going to start here and come down. So this is actually going to look like this, but I'm not going to have a center at 0, 0. I'm going to have a shift of 2. So it's going to come down and then look like that. All right, number 16, here's another polynomial function. And on this one, if I look at my x-intercepts, I have an x-intercept at 0, at -2, and at +2. So here's -2, here's 0, and here's +2. Now, this is a degree of 3, 4, 5. So this is going to be an odd function. So I'm going to have my arrows going in different directions. It's positive. This time, for all of my x-intercepts, the multiplicity is odd, so I'm not going to have any bounces. So I'm going to start here, I'm going to go up, I'm going to come down, and I'm going to go up and through. All right, so my arrows are in opposite direction because it's odd, and it goes through each of the x-intercepts. Number 17 is a rational function. Now, a rational function usually has a parent function, and it's a rational function with a squared on the denominator. I almost missed that. So this would be the parent function of that, but this time it shifted 2 units to the left. So I've kind of got this asymptote here, and I have an asymptote here. So instead of having my 2 branches be kind of centered around the origin, this time they're going to be centered around the equation x equals 0 through the y-axis. So it's going to look like this. Okay, it's just shifted 2 units to the left. Number 18. This is a rational function. This is what we were working on a lot in chapter 4. And here, first thing I need to do is identify my domain. So my domain is all x, and I'm going to factor this, x minus 4 and x plus 3. So x cannot equal 4 or negative 3. And if it does, I don't have any matching factors on the top, so these are my vertical asymptotes. So at negative 3 and 4, I have vertical asymptotes. The x-intercepts come from the zeros on the numerator, so the x-intercept is 0, so that would be the point 0, 0, so that's also the y-intercept. So I know I have a y-intercept here. Now I want to look for horizontal or slant asymptotes. Because my denominator or degree in the numerator and the denominator are equal, they both are degree of 2. So I'm going to have a horizontal asymptote at wherever the coefficients are going to be. So at y equal, both of these are 1. So at y equals 1, I have a horizontal asymptote here. So now I need to determine where do I have positive and negative parts of my graph. So the important parts on the x-axis are at negative 3, and at 0 I have an intercept, and at positive 4. So at negative 3, if I plug in negative 3, I have a positive on the top because negative 3 squared is positive, and on the bottom I have negative 3 minus 4 is a negative, and negative, let's try negative 4. I shouldn't use that. Negative 3. It needs to be to the left. So if I have negative 4 minus 4, that's a negative, and negative 4 plus 3 is a negative. So this value here is positive. So the only area to the left of negative 3 that would be all positive is in this section right here. Okay. Then I have the section between negative 3 and 0. So let's choose x equals 1 here. If I plug in 1 on the top, I get a positive. 1 minus 4 is negative, and 1 plus 3 is positive. So this area right here is negative. And I did that for 1. Let's do it for negative 1 as well. Negative 1 squared is positive. It's always going to be positive on the top. But -1 minus 4 is -5, and -1 plus 3 is positive, so this is negative. So both sides of this x and y intercept are going to be negative. So at this point, they're both pointing down. So they're going to approach the asymptote here. It's like a parabola. And to the right of 4, let's pick 5. So if x is 5, 5 squared is positive. 5 minus 4 is positive. 5 plus 3 is positive. All those values are positive here. These are both negative. So the only place that it would be all positive values would be up here. If I did anything with this, I would have to have a change of sign. I would have to go through the x-axis, and I don't have any other x-intercepts. So the only way I can keep this all positive is if this approaches the horizontal asymptote. Number 19 is a rational function, and this is the same as 1 over x. So if I have 2 over x, I'm going to have a vertical asymptote at x minus 3. So, sorry, I haven't, my denominator cannot equal 3. So I have a vertical asymptote at 3. So a rational function that's 1 over x looks like this. And it's basically just shifted over 3 units to the right. So it would be like this on both sides of that asymptote. All right, so moving on to number 20. And number 20, I have a rational function. And here I need to first identify my domain. So my domain is x cannot equal -2. If I factor the top, I have a x plus 1 and an x minus 1 over an x plus 2. So I cannot have x equals -2. I don't like this here. I'm going to move this over. So at -2, I will have a vertical asymptote. My x-intercepts come from the zeros in the numerator. So x-intercepts, x is -1 and x equals 1 are the intercepts. So at -1 and at +1. My y-intercept, if I plug in 0 for x, I'm going to have a -1 on top. If I plug in 0 for y, I'm going to have a 2, or plug in 0 for x, I'm going to have a 2 on bottom. So this is -1/2. So if this is 1, this is a y-intercept of -1/2. In terms of horizontal or slant asymptotes, my numerator is bigger than the denominator by 1. So I'm going to divide x into x squared. So it's going to look like x plus 2 into x squared minus 1. X squared plus 0x minus 1. So this will become an x, and I have x squared plus 2x here. I'm subtracting. So 0 minus 2 is -2. X, bring down the 1. So x times -2 is -2x. And then this would be -4. I don't care what my remainder is. I know they cancel. So my slant asymptote is at y equals x minus 2. So this is a linear equation. So I make a line, and now I just need to determine what my values are. So let's use this number line here. I need to look at the important x values. So at -2, I need to look at both sides of that, -1, and then 1. And those are the three things that are important in terms of x. So this is what I'm using for my factors. So if I have x is -3, -3 plus 1 is negative, -3 minus 1 is negative, and -3 plus 2 is negative. All right, so to the left of -2, the only place I can keep all my values negative are in this space right here. Okay, so then I have between -2 and 1. So let's do -1.5. At -1.5, plug it in here. -1.5 plus 1 is positive. Nope, it's negative, sorry. So let's do negative here. -1.5 minus 1 is negative, and when I add 2, I get a positive value. So this section in between -2 and -1 is positive. So from an x-intercept, this has to be positive, and I know this has to be negative because it's going to go through my x-intercept, and it's going to hit my y-intercept, and I'm projecting that it's going to go up this way. But if I just pick those values like x equals -1/2, add 1 to it, I get a positive value, then a negative value, and then -1/2 plus 2 is positive. So I was right that to the right of -1 is negative. And then between 0 and 1, I have +1/2. Add 1 to +1/2, I get a positive. Subtract 1, a negative, and add 2 is a positive. So here I still have a negative between 0 and 1. All right, so I'm looking between -1 and 1. All of this is 0. Even though 0 wasn't an x-intercept, I'm just kind of checking in between here to verify that I thought this was going to come and hit this, and it's going to turn, and to the right side of 1, let's say I pick x equals 3. 3 plus 1 is 4, that's positive, -1 is positive, and plus 2 is positive. So it's going to continue to go up here. So I've got this little section down here, and then almost parabolic down here. Now for 21 through 25, I just realized that these are inequalities, so I don't actually have to draw the graph. On some of them I think though I will. Here I'm looking for the x-intercepts, so I know x is 2 and x is -5. So here's -5, here's 2, and it's a parabola because this is quadratic, so it's going to come down here and that's going to go up. And I'm looking for values that are less than or equal to 0. So it's actually including the zeros this section right here. And my solution set for that would be including -5 and going up and including 2. This right here is something that I can factor. And if I look at this, if I look at both of these are both squares. So I have the difference of squares. So this is the same thing as x squared plus 4 and x squared minus 4 is greater than 0. So then I have x squared plus 4. This I can break down into the difference of squares as well. X plus 2 and x minus 2 is greater than 0. So here I'm not able to factor that, so there isn't a solution there. But I do have x-intercepts at -2 and +2. So these are intercepts. So at -2 and at +2, I have intercepts, and this is positive, so it is kind of pointing upwards, kind of a little flat here because of the 4th power. So now I'm looking for the area or the region where it's greater than 0. It's not including our zeros, so this is an open dot, so it kind of looks like a smiley face there. But my solution set would be -infinity up to -2, -infinity to 2, and a union of 2 to infinity. All right, so this is my solution set. Number 23, this is a rational function. I want the positive values greater than 0, not including the intercepts. So the first thing I'm going to do is look for my domain. And my domain is for all x cannot equal 3. And for my x-intercepts, I have x equals 0. So I have an x equals 0 and an x equals 3 that are important for my x values. And this is actually a vertical asymptote. And this is an x-intercept. So to the left of 0, I need to find out what would that be, positive or negative. So 2 times 0, let's do -1. 2 times -1 is negative. -1 minus 3 doesn't matter what it is because when I square it, I get a positive. So this area is negative. Between -1 and 0, like at x equals -1/2, 2 times -1/2 is negative, and the bottom is always going to be positive, so this is negative. Between 0 and 3, this is positive, so I have a positive. Let's say I pick x equals 1, so that's +2. And 1 minus 3 is -2, but I square it, I get a positive. So this is positive. And greater than 3, let's choose 4. So if x equals 4, 2 times 4 is positive, and positive on the bottom, so this is positive. All right, so what I'm looking for are values that are positive, and that would be between 0 and 3, I can't include any intercepts, and I can't include the 3 because it's a vertical asymptote. It's not in my domain. And anything greater than 3 is positive. So my solution set here would be between 0 and 3 and between 3 and infinity. Number 24, I'm going to factor the top and I get x plus 2 and x minus 2. On the denominator, I have an x plus 1 and an x plus 1. So for my domain, x cannot equal positive 1 or negative 1. And for my x-intercepts, I have a positive 2 and a negative 2. So x cannot equal 1 or negative 1. Okay, so I'm going to leave open circles here because they cannot equal. And x cannot equal 2 or negative, I'm sorry, x can equal 2 or negative 2. Those are my x-intercepts. So 1, negative 2. And because I'm looking for just negative values, I'm going to have open circles on these as well because I'm not going to include my zeros. So I have lots of sections to check here. So to the left of negative 2, if I plug in negative 3, negative 3 plus 2 is negative. Negative 3 minus 2 is negative. Negative 3 plus 1 is negative, and another negative. So 4 negatives gives me a positive value here. Between negative 1 and negative 2, I have negative 1.5. If I add 2, I get a positive value. Negative 1/2 minus 2 is negative, and both of these are negative. So this is negative in between here. Between negative 1 and positive 1, let's choose 0. If x is 0, I have positive, negative, and on bottom I have positive, positive. So this is negative right here, all the way between negative 1 and 1. Between 1 and 2, let's choose 1.5. 1.5 plus 2 is positive. 1.5 minus 2 is negative. And 1.5 plus, so this is negative. I'm thinking I might have made some kind of error, but I'm going to check here in a second. And then something bigger than 2, x is 3. 3 plus 2 is positive, 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 positive. So this is positive. I just want to check here again. Positive, negative, positive, positive. Negative 1.5. Minus, 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 plus. Okay, so it looks good. So I'm looking for numbers that are less than 0. So I actually have 3 sections here. I have between negative 2 and negative 1, but I can't include these values. And then I have negative here and negative here. So I have a union of 3 sets. So I'm going to have between negative 2 and negative 1, with between negative 1 and positive 1, and another set of between 1 and 2. Haven't had a three-part solution yet, but that's what it is. And actually, I'm going to show you this very messy graph that I did. I'm going to zoom in here. So this is what I'm looking at. I have a negative section here. I've got a negative section here. And then I have a negative section here. And can I include 0? Is 0 an x-intercept? It is. So whoops. 0 is not an x-intercept. So all of this was negative in between here. So that's all included. And this last one, I already brought one part of the equation over to the side, and I have to get a common denominator. So my common denominator would be x minus 2 and x plus 1. So I have to multiply 2 by x plus 1 in the numerator, and I have to multiply 3 by x minus 2. Oops. 3 times x minus 2, and this gives me on the numerator 2x plus 2 plus 3x minus 6, which is 5x minus 4, and on the denominator x minus 2 and x plus 1. So I'm looking for my domain. My domain is all numbers except for -2 and, I'm sorry, x cannot equal 2 and x cannot equal -1. So here's -1, here is 2. My x-intercept is positive 4/5 because this equals 0 is my x-intercept. So I add 4, divide by 5. My x-intercept is 4/5. So over almost to 1. So I'm checking these regions right here. So at -2, and this is where I'm checking, less than -1 is -2. So -2 plus 5 is -10 minus 4. So this would be negative on top. -2 minus 2 is negative on bottom, and plus 1 is negative. So this is negative. Between -1 and 4/5. So let's try 0. If I plug in 0, I have -4 on top. 0 minus 2 is -2, and 0 plus 1. So the two negatives make a positive. This section is positive. Now I have between 4/5 and 2. So I can choose 1. If I put in 1, 5 minus 4, that's positive. 1 minus 2 is negative. 1 plus 1 is positive, so this is negative. And bigger than 2, like x is 5, this is positive, positive. So all three of these are positive, so this is positive. I'm looking for less than or equal to 0. Okay, so I'm looking for the negatives, and I can include anything that's not a vertical asymptote. So this is a vertical asymptote, and this is, so I can't include these. So my solution set is -infinity to -1. Can't include it because it's not part of the domain. It would make the denominator 0. And the other part is from 2 to infinity. And that's the solution there. All right, that was a long one, but I hope it was worth it.